So section 2.3 is going to discuss ways by which we can display data. And we'll start out with a couple of simple ways, but they're pretty novel in the sense that not only are you summarizing your data, but you still have the data itself. So in particular, we're going to start out with this dot plot. Now, each one of these dots represents a piece of data. But the unique thing about this is by stacking them like we have, you can see, for instance, that there's, looks like about 6 different pieces of data right there at 60. And then one at 40 and one at, say, 42. So if we really needed to, we could take this display and recreate the data. And that's kind of cool because a lot of times when you look back at, for instance, what we did with our data in section 2.2, when we were summarizing things in terms of a histogram, you've lost the original data. I mean, I know that there's a lot of data, in fact, 37 observations in the range of 200 to 249, but I don't have what those were. So it's kind of nice that you can display the data in such a way that it preserves the data. Now, dot plot is one way that you can do this. Another way you can do this is with something called a stem and leaf plot. And for that, let me turn to some data that we have over here. Stem and leaf plot is, again, kind of a novel way to display some data. And it's eventually going to look like a sideways histogram. So what we'll do is we'll break up this data into 2 parts. There's the stem part. So like the first 2 numbers in this, 20, 21, 22, 23, and 24. That's the stem part. So let's draw ourselves a little bar here. And then to create the leaves, what you're going to do is say, okay, well, this first observation was 203. So it's 203. And then the next one was 205. So all I'm going to do is just put the end part of this. So 203, 205. There's nothing in the 210s. 221, 225, 229. And so at the same time, we have the original data, but it's also filling out things to the right, showing you the frequency with which we have that data. So let's finish up a couple more here. You know, I drew this in the wrong spot, didn't I? Oh, man. I should have skipped over this. It should be down here, 1, 5, and 9. And now we'll move down to the 230s. So 233, 235, 236, 237, 238, 238 again, and 239. So it's kind of like I said, a sideways histogram, but it's giving you an idea of the distribution of the data. But at the same time, if you wanted to or needed to, you could recreate the original data set. So that's kind of a novel way to display data. It's called a stem and leaf plot. Stem and leaf plot. Now, this is probably only going to be effective for smaller data sets, not larger data sets, but it's just one of a number of ways we have to display some data. So, looking okay with that one? I mean, if you were to flip it up, it'd be pretty much a histogram. All right, so let's keep going and looking through here. So a time series. This is when your data actually represents 2 things. It was collected at a certain time, perhaps a year, and then you've got a number. So you can display this as a series of these numbers, and then you connect them with a little polygon like you've done here. And you can look for trends or spikes, what have you. But this is called a time series graph. And we'll do one in just a little bit. In fact, you know what? Maybe we can do things now. Let me see here. Yeah, let's do one in Google Sheets. So what I'll do is I'll put some data in the chat. And you can pick up the data in the chat. So, yeah, let's see.
So you want us to start a new sheet for this one?
Yeah, it'd probably be easiest, or just
Okay.
or just put it in an empty column someplace.
Okay.
So grab that data and then paste it in, and then go over and highlight that data. And what this represents is the number of home runs hit by major leaguers starting in 1990. So this is problem number 10 if you're actually to pull out a physical copy of the book. Let's see, do I have that up here? Can I go to that page? That'd be page 65. So I don't know why their website is so slow. There you go. Listed below are the numbers of home runs in the Major League and home runs in Major League Baseball for each year beginning with 1990, listed in order by row. Is there a trend? So to spot a trend, you're going to try and do a time series plot. So one way you can do those is in Google Sheets. You paste in your data, you highlight it, and then you want Google to chart it. And in this case, it's pretty nice because Google will figure out exactly what you want. So you come down to chart, click chart, and it's just going to figure out everything for you. Wow, that's pretty cool. So there's your chart of the number of home runs hit by Major League Baseball. How would you describe the change over time? How's it proceeded for the MLB?
It's gone up, and then it like kind of plateaued.
Yeah, gone up for a while, and really got up, and then it started phasing out. And I don't pretend to be much of a historian in baseball, but I know for a while they were having problems with steroids. So maybe, in this year, that's where they started cracking down on the steroid use, and the number of home runs started to diminish. So, yeah.
I'm sorry. How did I put the data in? But now I'm. How did we switch over to this timesheet? Was it no?
So what you need to do is you want to highlight your data. So
Yeah.
click and drag.
Mm-hmm.
And once you got all your data highlighted, underneath Insert, scroll down and hit Chart. And it should just pop up with a nice, neat chart here for you.
Ah, all right, got it. Thank you.
Mm-hmm. No problem. Thank you. Let's go back and look at some other ways that you can display some data. And some of these are probably going to be familiar to you, and that's fine. Here's one that's basically you're taking your frequency histogram and putting the class that's most frequent first and closest to the y-axis, followed by the next most populous class, and then so on, diminishing as far as you go to the right. So it goes from highest to lowest, from left to right. And if you do that, if you order your frequency histogram, it's no longer called a frequency histogram, it's called a Pareto chart. So, just something to know as you do your homework, that when you do a Pareto chart, it's in decreasing order of frequency from left to right. Pie charts, again, like I said, Some of this stuff is going to look familiar to you. This one is talking about the distribution of stolen boats. What's the most stolen item in this chart? What do people target the most?
Jet skis.
Jet skis.
Yeah. So what happens here is the proportion of jet skis stolen in this data set is displayed as this area, and that area is proportional to the proportion of jet skis stolen. So yeah, you can see that almost half of the crafts stolen appear to be jet skis. So nice. Now, let's see. Instead of plotting frequency histograms, another thing you can do is you can just plot points. So this service time in terms of seconds occurred with a frequency of about 11 or so. Put a point there. But instead of putting a bar here for a frequency histogram, you can connect those bars with a polygon and get a frequency polygon instead of a frequency histogram. So again, a different way to display things. Is one better than the other? Yeah, you know, it's up to you. Who knows? I think I like the frequency histograms a little bit better, but frequency polygons display the same information. Now let's look at graphs that deceive. So here's a good one. If you're familiar with placebos, placebos are sometimes given in clinical trial experiments so that they can try and decide if people are getting better because they want to get better or expect to get better. Now in this case, they're testing OxyContin for a percentage of people who experience nausea. And if you don't want nausea, I think I'd be much happier taking the placebo pill than the OxyContin pill here. Just look at this. You're way more likely to get nausea given that you received OxyContin as opposed to a placebo. But there's something misleading about this graph, something really misleading. And what is it? Can you tell anything?
Starts at 10%.
Yes, it starts at 10%. And what that does is it exaggerates this difference. So if we start at 0, like we do over here, then, oh, well, yeah, I mean, OxyContin still, you know, isn't that great. I mean, a lot of people, I mean, almost a quarter of subjects experience nausea, but there's a lot of people who get a placebo that still experience nausea. So the difference isn't nearly as dramatic here as it is with the first graph. And that's because somebody started this graph at a place other than 0. So it's not the first time or last time I'll say there's 3 kinds of lies: lies, damn lies, and statistics. All right, it's easy to mislead people with statistics unless you're being very, very careful and looking at things. And a quick glance at this graph, you're like, woo, stay away from OxyContin. Comments or questions on that? Let's move down to this one. Number of cigarette smokers in 1970 was 37% of US adults. Wow. By 2013, it dropped down to 18% of 18% of adults. Now, when you look at this, they've drawn a cigarette here that's twice as long as they drew here. But I don't know, if you were just looking at the cigarettes themselves, what impression does it give? Does it give an impression that we just cut it in half?
Yeah, it's meant more for, I guess, visual stimulation than actual data representation.
Well, it doesn't do a fair job of data representation in my mind, because this cigarette looks a lot less than 1/2 the size of this one, right? That's because the cigarette is portrayed using an area, and they cut down the area twice. They cut down the area in half one way and in half the other direction. So really, this is about 1/4 of the size of this. But you're using an area which has 2 dimensions to represent a change of something that has 1 dimension. So that's why this looks like a great exaggeration of how much you've decreased the number of smokers over those intervening, 43 years. So it's misleading because this cigarette is a lot smaller than just half of this one. Let's look at that kind of thing again. Where is it? I thought I had another one like that. There's probably some in the homework. So let's take a quick look through the homework. One thing I don't like about this website is that it seems to take forever to load these pages. Same thing's going on here. Price of token or a subway fare in New York City was $1 in 1986. And then this is the current standard. Just looking at these relative to one another, how much would you guess the current subway fare is?
I guess it's a lot.
$4.
Yeah, it looks like you could easily fit 4 of these in this new subway fare, right? Whereas actually it's only 2.5 is the subway fare. But that's again because you're using something with 2 dimensions to represent an increase in something that only has 1 dimension to it. And that's just the price. So you got to be careful when you're doing these kinds of pictures, these pictographs, to depict a change in something that only has 1 dimension. So there's a couple ways you can deceive with these types of graphs. What's the problem with this graph between the comfortable and not comfortable?
It starts at 200.
Yeah, doesn't start at 0. So again, you're exaggerating this difference. Looks like you're trying to say, hey, look, you know what? Most people aren't comfortable. And it's true, there's a lot of people that aren't comfortable, but the difference isn't quite as much as would be implied by this graph. Now, those were some kind of basic graphs. Let me see if I can't find kind of a really cool graph here for us. Pull that one up. Yeah, this guy's. Now, I gotta tell you, I'm not making any political statement here.
All right, here's the Andrew Yang argument.
All right, and I think I might have to go back and optimize this a little bit. So give me 1 second. So I want to make sure that you can hear this. Let's see. Move. Share. Okay. Can you hear this guy? Can you see him?
60 seconds or less. Andrew Yang ran for president last year.
All right.
Yep.
Can you hear him?
Yeah.
Thank you. All right. Let's give this a shot. Just watch his data display. It's amazing. And he's standing in his garage, too. That's so cool.
His main argument was that the reason Donald Trump won the 2016 election was because of the loss of manufacturing jobs in the U.S. So we can see here, this is looking at 1939 to today, that the peak was around 1979, where we had almost 20 million manufacturing jobs. But today, we're around 12.8 million. And that really it's around 2000. From 2000 on, we see this decline in the number of jobs in manufacturing. And so his argument is that those job losses are really played out in key swing states, and that's where the election was lost. And so let's look at those actual states. So let's break this out, and we can see that, yes, in Indiana, Michigan, Missouri, Ohio, Pennsylvania, Wisconsin, that yes, there was that precipitous decline in jobs. So that part of the argument does hold up. And his real point is, what's next? Where's automation leading to next?
All right, so there's a part 2. I'm sorry I don't have this joined in part 1 and part 2, but let me pull up part 2. Because again, it's some more really cool data display.
Point is, what's next? Where's automation leading to next? And so if we look at each of these dots that represents 4,000 US workers and start to order them, where are they working? They're working in retail. There are people working in food services, people working as truck drivers. That these are the next jobs to be automated. And where does that leave us as a country when we lose those jobs? And I think especially now with COVID helping propel the automation forward even faster, how do we move forward as a country? And I think I love his statement, not left, not right, but forward. Thank you.
Cool. So if you can figure out exactly how he does this and share with me, I'll give you extra credit. That's pretty cool. I mean, I don't know. What do you think?
I think it's flow. It says at the top of the screen there. I think you can probably download it on your phone and manually input it. I can look it up if you want me to.
Probably also involves some, at least having, some working knowledge of, digital arts and media, or having someone else or maybe even a team to help with that, because that was very slick.
That was pretty cool. So now not everything has to be that high tech to get across a lot of information. And let's just take a look at one last historical graph that is probably one of the most famous, what's called infographs in the history of the world. And this is a graph of Napoleon's March against Russia during the years 1812 to 1813. And it just shows so much information and really tells a story of, what happened to that disastrous march on Moscow. And first of all, it shows the dates and it shows all the temperatures. And it was really cold. Unfortunately for the soldiers, Napoleon's army was outfitted for, like summer fighting, not for winter fighting. And as they marched towards Moscow, the Russian army would just fall back and burn the earth behind them so that the advancing French army couldn't live off the land. So, and as they marched forward and forward, frostbite and malnutrition, desertion took its toll. And look at what happened to this mighty army of over 400,000 as you move further and further out towards Moscow. And finally, they cut out with the Russians and fought a battle a little outside of Moscow. But by the time they got to Moscow, the Russians burned down Moscow. There was nothing to conquer. And so then they had to come back, all the way back, and you see the dates and see the temperatures. And look what happened to that army. I mean, 400,000 left, and like 10,000 came back. Wow, what a disaster. So it's just an amazing piece of work to incorporate like 6 different aspects of data into one pictograph, infograph. Outstanding. Well done there. So there's a lot of ways you can display data, and I don't want you to just be pigeonholed into just a couple of them. I mean, try and be creative, etc. But there's you don't have to be as high tech as that one guy doing his Andrew Yang presentation, but try and be thoughtful in whatever medium you choose there. So, all right. Any other comments or questions for section 6 or 2.3? Doing good there? All right. Let me stop this.